Hello, and welcome to SOH, the best office hours, because you are a part of it. This is Calculus AB 2024, question number 3. Let's see what's about. The depth of seawater at a location can be modeled by this function with that differential equation. Okay, congratulations. Now, there is an initial condition here that is very important to notice, as always, because we will have to use it at the end. And what else? Oh, there are units, feet. That's also very important, just in case. Hours, and also afternoon. Okay, cool. Yes. A portion of the slope of the field. Well, usually when you have to sketch those solutions, let's first go over what we need to do, like highlights in one or 2 minutes. And then after that, I will go one by one. So maybe you are done in a couple of minutes. So how do you do that sketch? You just join these lines. So you're here, 0.4, right? And let's change to a pen, and then we have to follow, just join these dotted lines. Sometimes you may think, I don't have exactly one dotted line, just approximately. That's it, that's A, end of the story. B, it has a critical point. Okay, let's see how critical it is. And then if it's a relative minimum, maximum, or neither. Okay, cool, and justify your answer. Well, look at that. I don't think that's going to work, but you can see that, well, from my previous plot, I see that there is a maximum, which is local, so it's a relative maximum, and if I go down, it's very close to 3. Which famous number is close to 3 with trigonometric functions? Pi. Yay. Let's get an apple pie. So the point is that might not be considered a proper justification, even though it is, right? I mean, pi is not justified, but what else can it be if we have a cosine? But anyway, we will do it step by step, and as you know, what we are going to do is that the derivative is going to be 0, okay? And then investigate about that. Now, last one is, it happens very often that we are asked to solve something that is done with separation of variables. And that's a very commonplace method to solve some differential equations that we find very often, especially in physics. So, at college level, if you solve even the hydrogen atom, quantum mechanics, and other stuff, they usually have, or standing waves, they usually have a differential equation that can be solved by separation of variables. So here we have a first step of separation of variables. In college you will have a second step, maybe 20 more steps. Don't be afraid, that's okay. And yeah, that's the basis. So what does it mean? We put like apples with apples, oranges with oranges, brothers with brothers, sisters with sisters, then we integrate initial condition and happy family. So in this case, what it means in practice, that you would need to put maybe on the left all the h's and on the right all the t's, then integrate, right? Yes, integrate plus initial condition. And then you get a nice fun, which should be this curve, by the way, right? Should be exactly this curve here. Okay. And you can see this kind of oscillation is brought by the cosine. Where is the cosine? Here it is. So yeah, I know, nice problem. If you have enough with this, go for your 5, call me when you got it, and go to the infinite minus 1 other AP problems that you may find. If you are interested in knowing a little bit more about it, then let's continue. Let's go. So A was pretty simple, so if you don't mind, yep, we rather are done earlier than later. That's what we have, right? Just join the dots. Great, thank you for asking. Now B. So B, we have to actually find that minimum. That again, let's put it here. But we know that it's going to be around pi, blah, 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 blah. And it's a relative maximum, so that's great. Thank you so much. So how do we do that? First of all, remember a critical point. You do the derivative equal to 0. So you're going to solve this equation. And it has 2 terms, right? It has like this term here, and then this term here. Now, because of this condition, this is different from 0. So when you have the equation equal to 0, the only one that remains that you need to carry is this one. This is a trigonometric equation. If you don't remember how this works, whatever, remember at least that you have a circle, and then cosine is usually this guy, the horizontal one. That's the cosine, okay? And so this means that basically you have 2 places where this cosine is 0. It's like when you have 90 degrees and 270 degrees. Now, we are at this level, AP, college, we are not using degrees, we use radians. So basically you have t divided by 2 should be 90 degrees by half radians, or t divided by 2 should be 3 pi divided by 2. If you are really interested in solving these equations properly, we should add a number of terms, because you can go back as many terms as you want, or even backwards, right? So plus any number of terms where k is an integer, okay, integer. Woohoo. Okay. However, we have to stay at in this interval, and indeed you can see that. Well, let's multiply by 2 first, right? But you can see that only one of them is going to work. But let's see, we have t equals to pi plus 4 pi k, or t, or 3 pi plus 4 pi k. Okay, k is an integer. So you can see from all these that only one case, k equal to 0, and the first case has a number that is between 0 and 5, because it's 3.14, 15, 9, and I don't remember the next ones, but anyway, it's cool. Had a student who had memorized, I think, the first 200 digits of 5, and that's why she got into college. No, not joking. I mean, she had other things, but that was one of the things in the resume or essays. Okay. Okay, yeah, I think that when I asked her, freshman, she had already forgotten, but she was already in college. You know what you have to do, right, to get into college, this kind of crazy stuff. So, okay, let's move on. That's where we are. So, let's prove that this is a maximum. So there are two ways. Either you compute the second derivative, if you can, or with the first derivative. Let's see what happens with the first derivative. We think that this is a maximum. So before the maximum, the slope is positive, and after the maximum, the slope is negative, right? So we should prove that dh dt before pi is positive or negative. Okay, let's write first the expression of the derivative to see whether that's something easy to do. 1/2 h minus 1 cosine of t divided by 2. We also see from here that, you know, h is greater than 1. We can see that here. So in other words, all this is positive. So what you need to worry is about the sign of this. What happens if we look for, let's say, t equal to 3, which is less than pi, right, before? So we are going to have something that is going to go like 1/2 of h of 3 minus 1 multiplied by cosine of 3/2. And of course, we don't know how much is the cosine of 3/2, no idea. But we know that this is positive. But we know because of the circle that if we are before the pi half, the cosine is positive. It's this thing here, right? Remember, this is the cosine. So, well, this is going to be positive, so you have that this is positive. And then if we go after pi, we know that this is a maximum, but we have to justify it. Let's say 4, maybe. You know, it's after. So then we will have 1/2 of h of 4 minus 1, which we know that all this is positive, cosine of 2. And we have no idea how much is cosine of 2. I mean, I don't. But I know that cosine of pi halves is here. We know it's a little bit after. So, you know, you don't even need to know very much. You just know that you crossed this point. So it's going to be negative, right? Here the cosine, and here was positive. So this is negative. That's the point. So what you get is this is negative. So in other words, you've proven that you have something that first is positive and then is negative. So therefore, x equal to pi is a relative maximum. Okay, justified. Another way is to use the second derivative, but in order to do that, we need to compute. So this is an alternative, okay, alternate way to compute this. Okay, how do we do that? Well, you have to take a second derivative. It's not a bad idea to know how to do it, because there are other problems where you must do this. Like 2023, you had to. So in this case, well, dh dt is another derivative, so we have to take another derivative, bunch of derivatives. You will get to do thousands of derivatives in your life. So one more, that's not hard. And then you have a quotient here, so this is 1/2. Then the derivative of h divided by dt, right? Cosine of t divided by 2, because it's a product, and then plus 1/2 h minus 1, and then the derivative of cosine. The derivative of cosine is minus sine, right? So multiply by minus sine t divided by 2, and then chain rule 1/2. So let's be careful with all this, because it's easy to lose some of these factors, right? So 1/2 of dh, this is a kind of a long expression, but don't be so much worried. It will simplify a lot in a second. You will see why. So this minus this, well, let's put here minus 1/4 if you don't mind, right, to have a little bit less of mess here, and this. Why am I saying that this is going to simplify? This is the second derivative, right? That's a beautiful expression. Because we need to compute it at t equal to pi. And you know that the derivative is 0 at t equal to pi. So this thing here is 0, okay? And so you only have minus 1/4 of h of pi, you know, h of pi minus 1 multiplied by sine of pi halves. Sine of pi halves is 1 because it's 90 degrees and the sine, remember, is this vertical thing here, so it's 1. So this is 1. And this is positive, but here we have a negative, so this is negative. So if you remember, when you had that the second derivative was negative, it corresponds to a relative maximum, so we get the same answer. So great, let's go for the last one, C. Yes, here it is, C. Okay, let's see C. So what we have is to solve this by separation of variables. And as you know, this is apples with apples, oranges with oranges, and let's move on. So what are the apples? Well, today apples will be H, and oranges will be T, okay? But again, this is a very important methodology that is used in quantum mechanics and other fields. So, you know, yep, you want to sound cool, then you say, well, I do separation of variables for breakfast. So the point is, we have to put things on one side and the other side. For instance, we decided to put this on the left, and the reason is because you have DH, right? So DH, let's put all the H's here. Now I'm also going to put the number 2 here because I don't want to have quotients. I forget about quotients sometimes. And then cosine of t divided by 2, and then dt. And now the next thing that we have to do is to integrate, right? That lovely thing that we like to do. And how do you do that? Well, some of you may know this without blinking, but some others, we always need to learn. There's no baby that knows how to integrate, right? So we need to learn at some point. So one of the things that we memorize is, or we look in tables, is the result of this integral. And we would like this to be this, but it's not. So then what you do is change of variables. So you use the method of change of variable. This is optional. This is the end of the video. So if you had enough, you know, that's okay. Or you can skip to the final solution when we use the initial condition. But I want to explain what's the change of variable, how to deal with it. There are different ways, different people, different flavors. One way is the following. Imagine that you have an integral that is in terms of x, and for some reason you want to use some change of variable, okay, some variable. Then you have to compute the derivative of this function, okay? And then the new integral is going to be that function, but replacing, you know, your combination here, and it's going to look a different function. That's okay, sometimes. And then you're going to replace this by this, and then divide by u prime, because you need that to have the same as dx. That's one way of explaining it. There are other ways, okay? So let's use a blank page here. So let's do that. What would be our change of variable here? Well, we would like h minus 1 to disappear, right? So how much is u prime? Is just 1, okay? So when we go to this integral that we have here, now be very careful that there was a number 2 here. We don't want to forget it later. So this is going to be du divided by u, not yourself, that just this u, and then we have u prime here, okay? Don't forget that, because sometimes this can be a minus 1 or a 1/2, something like that. But in this case, we just have this. So this is this, right? And there is the absolute value, which is pretty important in general. So let's be careful with that. Okay, so what about the other side? What about the cosine of t divided by 2 dt? Also, we have to do a change of variable, t divided by 2. In this case, u prime is 1/2. So in this case, it will matter. So this is going to be the integral of the cosine of u du divided by u prime, 1/2. That goes out like a 2. Of course, there are other methods to explain this, and you may prefer the method that you have heard in class, or you have self-taught yourself. So that's up to you. How much is this integral? Twice the sine of u plus another constant, arbitrary constant. Let's put all this together. So the first one, remember the change was h minus 1. So for the first case, what we have is that the integral of dh divided by h minus 1 is going to be the logarithm of the absolute value of h minus 1 plus the famous arbitrary constant. For the other case, cosine of t2 dt, we are going to have that is twice the sine of t divided by 2 plus the arbitrary constant. Now we have to make them just equal to each other. Remember that we have a factor 2 here. That's very important. So what we need to do is twice the logarithm of h minus 1 plus that famous constant. So just forget about the constant. Just write one constant equals this plus the famous arbitrary constant. If you want, it's C1, C2, C3, and you keep track of the arbitrary constants. But they are arbitrary, so you can rewrite them again and again. No one really cares about tracking this down. Okay, we have already a lot of stuff to do. So let's do it again. We have this. We're going to divide by 2, and I'm not going to change the number of C. Sorry, but that's how it is. Now, the absolute value is something important. If this is positive, then it's just the same thing, right? If x is positive, then this is equals to x. Remember that h indeed is greater than 1. You can see that like from the plot before, you know, and anyway, they tell you also here. So this means that this absolute value here, you can really write it like this if you like, okay? So, but in other cases, it may matter. So let's be careful with that. Okay. We need to find this arbitrary constant and then isolate finally h. So we still have a little bit of work to do. Let's add a new page. This one, okay, cool. And remember that the initial condition was h not equal to 4. Okay, so at time 0 in the afternoon, but we haven't used the afternoon at all the units, but anyway, it is 4, and it was fit, I think, anyway. So we go here and we say, okay, look, man, a logarithm of 3 equals the sine of what? 0 plus c. But the sine of 0 is 0, right? Remember here that the sine is this is the cosine, and the sine is the vertical part, right? This is kind of the sine. So when you're at angle 0, then you don't have any height, so that's just 0. And therefore, what you get here is that your famous arbitrary constant now is not anymore arbitrary. So we go here, we put all together, bum, 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 bum. Bum, 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 bum. And then we are going to isolate h. But we have this kind of thing. Logarithm of something equals to something. So x equals the exponential of that. And since we have two things, remember that we have this property. Maybe we learned that like, you know, like when we were in kindergarten, but don't forget about it. That was the first thing you learned in kindergarten. So let's do that, at least in mine. So that's why I'm doing all this, you know, I sleep with math. So then this is going to be this thing here and this thing here. But this is the reciprocal function, the same thing as here. So this is equal to 3. So you finally get this fantastic result that, you know, I would print a t-shirt with it, and don't wear it, just give it to your friends. It's not good enough to wear it, but you can give it to your friends once you get your 5 in the AP. Okay, so that's the solution. Now we're done, but of course it's nice to check whether we were right or not, especially if you have some time, right? So how do you check that? Well, of course, the first thing to check, which should work, is that the initial condition, indeed, it's good. So you know, if we didn't get anything wrong, so it's going to be like this and this. And this is 0, as we know, so this is 1 plus 3 times 1. Be careful, this is 1, okay? So this is 4, okay? It checks out. What else could we do to check that we are right? Well, you know, one of the things that we could do is to try to derive this expression here, right? Since we have the whole expression. So how do we do that? Well, let's see. Let's get that. But you're done, okay? If you're tired, whatever, you can just leave. See you in the next one. But how do we do that? So, because this happens many times, so I really recommend you to see it at least once and be able to do it if you have time. Separation of variables is also the longest problem, so maybe you could start with that. It does not depend on anything that we've done before, right? And you make sure that you have how much time you have to check it out and do the other questions, okay? Because separation of variables, if you have the ability to check it and you have it right, it gives you the full score, right? The other ones were quite fast. So let's see. We want to take the derivative of this function, and we have it here, okay? So, well, this is 0 plus 3, this chain rule, right? Cosine of t divided by 2, 1/2. So if we rearrange this in a nice way, maybe you would do that, maybe. And I'm writing the exponential behind the cosine, but it could be before, right? It depends on your choice. Now, is this the same thing as this one that we had at the beginning of the problem? It was, remember, let's see, it was 1/2 of h minus 1 cosine of t divided by 2. What about that? I'm sure that you also remember. Yes, so, well, we don't know, right? But we have this h here and here. So if we, and you have this combination here, these three, let's use a different color, 3 and this, and you have it here too. So you can realize that 3e to the power of sine t divided by 2 is h of t minus 1. And then we can write this thing here, let's write it, this thing here, like dh dt equals 1/2 cosine of t divided by 2, and this is h of t minus 1, which is exactly this thing. So we are great. Imagine that I would have forgotten this factor of 2 right here, which is easy because it's here. So we wouldn't have gotten that. Of course, one gets a bit crazy where the error might be, but it's worth, after spending 1 year working towards this, that you get most ways to check it. Okay, thank you so much. See you in the next one. Have a good one.